Right, everyone, welcome back to another video on how to do a cost of supply study. This video will be centered around the methodology inputs. And the methodology inputs are very important because they lay the foundation for a lot of the choices you make that allows the model to calculate your cost to supply electricity. So the choices you make here will determine how things come out at the end. So we're going to go through everything slowly. Okay, so the first step in the methodology inputs is the adopted revenue requirement approach. And so you can see here in this table, there are three different options. The first is number one, allowable return on regulated asset base. Number two, asset values annuitized at a selected discount rate. And option three, allowable surplus is calculated on the OPEX. What you can do is you can select which of these options applies to the wires side of the business and which applies to the retail side of the business. So you can see here, if I select number one, it then switches to allowable return on the regulated asset base. In the case of the retail business, you can see I've left it on a surplus factor. In this current example with both wires and retail being left on option three, you can see that the surplus factor here is 10%. I can change this to 11% if I would like, as an example, but I'll leave it as 10%. That's a number you can change. It needs to be changed in line with the NERSA framework. And then over here, you can select whether the OPEX is including purchases or excluding purchases, option one or option two. So your surplus will either calculate on 10% of your entire operational expenditure, including your power purchases, or excluding them. If you were to select option one here, we'll do it on both sides, you'll then be able to change the allowable rate of return. So you can see here that there's 2% for wires and 10% for retail. That you can change and it will be derived from your financial accounts. And if you were to select option two, over here, you see there's now a discount rate. This is a discount rate that will be applied to the total capex for both the wires and the retail. And again, it should be derived from your financial accounts. I'm going to switch them all back to number three for now. And you can see it's gone back to the 10% over here. When you get to step two over here, the selected approach to determine total value of assets for any particular year. This is for the user to select when the asset's value should be taken into account. So this will depend on when the entity is issuing the financial statement and the end of its financial year. So this will be based on how your finance department does the depreciation. In step three over here, the selected approach to determine network asset depreciation for any particular year. If you are using a deform-based value, then you will use the hard-coded inputs in financial inputs. So this comes directly from your deform, and it's the depreciation value that you can use. If you're using the asset register, then you will use option two. We'll change that like that. Change that back to number one. It's important to note, and I'll go into this in a bit of detail as well when we discuss the asset register, most municipalities won't have a fully updated, maintained asset register for their entire network. And that is what all municipalities should strive to achieve. However, in the interim, if you do not have that available, you can use your hard code financial inputs, all the while trying to get the asset register up to date so that you can get a more accurate reflection of your cost to supply. Section 4, the selected approach to determine retail asset depreciation for any particular year. It works the same as above. You can either use the hard-coded financial inputs or you can use the asset register. Step 5, selected approach to determine network asset operation and maintenance in any particular year. This again, you can use the asset register or the financial inputs. You can choose whether it's hard-coded or if it comes from the asset register. Then here at step 6, this is the selected approach to cap losses. So you can see that again, there's two choices. The first one is 100% of the energy purchase counts towards the revenue requirements. And number 2 over here, only the share of total purchase costs corresponding to sales plus maximum allowable losses count towards the revenue requirements. We've selected option 2 here, and you can decide which is more appropriate to you. Option 2 is the default setting in the tool at the moment. And then according to NERSA, the maximum allowable losses is 12%. Anything higher than 12% is deemed inefficient and not prudent and cannot be built into the tariffs. So we cap the losses here at 12%. And then on to step 7, the selected approach to allocate the cost of losses. This allows the user to decide whether to allocate the cost of the losses to retail cost or as a share between the wires and the retail business. So you can either say the cost of losses is all retail, or if you want, you can split it between the wires as well. And then you can say here, technical losses, are they 100% wires cost, or maybe it's 50% and 50%, you can decide. And then down to number 8, the selected approach to project future OPEX. This table here allows you to either use hard-coded RAND values or X-factor assumptions. And this links to the financial inputs years 1 to 4 tab. So in year 1, you will use hard-coded RAND values. In year 2, you'll use X-factor assumptions. You choose this, we select that to be number 1, it goes to hard-coded RAND figures. This links to information you use in your D form and how you project that into the future. We tend to keep it as is, using hard-coded RAND values from the D form in year 1, and then X-factor assumptions for years 2 and onwards. And this will make sense when we get to the financial input step. In step 9, it's the classification of ESCOM purchase costs. This table says you can either select 100% of the costs are treated as energy driven, or KVA purchase costs are treated as demand driven and fixed costs treated as customer driven. We keep it with option 2 because there are demand and fixed costs that are associated with your ESCOM purchase costs, and it's better than lumping it all into energy-driven costs. In step 10, the selected approach to year 0 depreciation inputs. You can choose between hard-coded RAND figures and use depreciation percentage assumptions. We use depreciation percentage assumptions. With step 11, selected approach to electricity sales forecasting. This is similar to a few steps earlier. You can either use hard-coded figures with kilowatt hours, or you can use percentage increases. So in the commercial inputs years 1 to 4, if you are predicting your future sales of electricity to your customers, you select whether you're going to use RAND figures or percentage increases in this area here. And then the last step in the methodology inputs is 12, which is the selected approach to customer-based forecasting. Again, this is linked to the commercial inputs years 1 to 4, where you forecast the number of electricity customers that the municipality is expecting to have in years 1 and 2. And you can either use sort of hard-coded straight number figures, or you can use a percentage increase. Once you've done that, you can then move on to the next step. And if at any point that during your study, you find that there's something that's not quite right, you can return to the methodology inputs to understand if there is an issue, and if you need to, you can change it.